Alright, let's take a look at section 1.4. In this section we're going to cover variables, describe variables in greater detail and ways of measuring them. So variables and measurement. Okay, so remember that a variable is a characteristic that we're going to measure that has values that change. So it's a varying characteristic, so I'll just say a characteristic with changing values. So a person's height, or the height of members in a certain population, something like that. Okay. Often though, we are looking at, especially in help fields, teaching, nursing, psychology, social work, things like that, we're looking at more intrinsic characteristics. So intelligence or emotions, pain, level of understanding, what is that? How would you define that? And so we're really describing, even though that could change, a person's level of understanding could be less than another person's level of understanding, so we can kind of measure it. It's still more of an intrinsic or an internal characteristic, and in that case we don't use the word variable for it, although it is varying. We use this idea of a construct. Okay, so a construct is an internal characteristic, internal attribute that is used to describe or explain behavior. So I'll say that helps describe and explain behavior. The trick is that constructs are difficult to measure. So how would you measure pain, or how would you measure intelligence in a meaningful way, since the way we measure it might be influencing the results? Okay, so whenever you deal with a construct, you also have to create what's known as a operational definition. Operational definition. Okay. So let's take a look at an example of an operational definition. So example, operational definition. Okay. An example we might be familiar with is ranking level of pain. So when you ask a patient, so I'll say level of pain, if you ask a patient something like, on a scale of 1 to 5, rank the level of pain you are experiencing. Okay. Here it's somebody might think a 4 applies to a broken bone, but somebody else might think a 2 applies. Maybe I should have set a scale of 1 to 10. So this is kind of a subjective measurement, and also it's highly influenced by the current condition of the patient. So as an operational definition, we have to provide not only a way to measure this construct, but a way to interpret the construct. So the measurement is a scale of 1 to 5. We'll talk about that measurement scale a little bit later on. But we also have to apply this idea that a 5 means the most pain you can experience in one means that it's negligible pain or very low level of pain, and so that would probably need to be communicated as well. On a scale from 1 to 5, if 5 is the most pain you've ever experienced in your life, please rank your current pain level. So to give a more definition-based approach to operational definition, it has to identify how the construct will be measured. So we must identify okay. So to give a definition to this, an operational definition must identify how the construct will be measured. And it also must give us a way to define or interpret results. Okay, so we also need a way explain how to define or interpret these results. Okay, so in the world of variables, there are two types of variables. Two types, Y and the P merge. Two types of variables. Okay, we have what's known as a discrete variable, and we have what's called a continuous variable. All right, so a discrete variable has distinct units, or I should say distinct values possible. So distinct values possible. Okay, so an example would be maybe a ranking, or rankings, because you can't rank 1.5. You're either first or you're second or you're third or you're fourth. It could also be categories, but it could also be something that's countable. Maybe I'll just say that, countable items. In other words, I have 5 apples, or I have 22 apples, and I suppose you could have 22.5 apples, but let's not go that route. Let's just say whole items, right? With continuous variables, you have an infinite amount of possibilities for those values. So infinitely many values possible. It doesn't mean everything is possible. For example, a continuous variable for patients maybe is a patient's height. Patient's height or weight. Okay, let's look at patient's height. Even though there are infinitely many heights available, we are limited in terms of you can't be less than 0 inches tall, or it's unlikely that you're more than 2,000 inches tall. I mean, you can refine it a little bit further, but it's somebody could be, for example, 91.2 inches. Somebody else could be 91.23 inches, and those are different. Okay, so with discrete variables are very easy to measure, but continuous variables, we need to take a look at some kind of cautions. So with continuous variables, I'll write it like this. Variables, there's two things we need to be aware of. First, it's rare to have identical measures. Have identical measurements. So in other words, no two people are exactly the same height. It just might be that the approximate value that we're using is the same. And that's really our second point. So not only is it rare to have identical measurements, we're actually using a range or an interval of values to measure. So each measurement is really an approximation. Okay, so back to the height example. If we're looking at a patient's height and we're saying that we're using a tape measure or a ruler on the wall, a yardstick on the wall or something, the tick marks on the measuring stick against the wall maybe go every 1/16 of an inch. Okay, so if we're dealing with a 1/16 of an inch, that means if somebody comes in and and has a height of 5 feet 3 and 2, well, that's not good, 3/16 of an inch, you can't measure in between 3/16 and 4/16 because you don't have that refinement on your measuring stick. And so it's that somebody would be in between 3/16 and 4/16 of an inch. Well, then we're just going to round one way or the other. Okay, so that's why it's impossible to have identical measurements, and it's really a range of values. So another example for this, if you're looking at a patient's temperature, your thermometer maybe gives you a temperature reading to the nearest tenth of a degree, let's say. So your thermometer reads to the nearest tenth of a degree. So a person could have, I suppose theoretically, any measurement possible for a temperature, although some are less likely than others. If you have a patient that has, a temperature of 98.7 degrees, that's not their exact temperature. We wouldn't be able to measure their exact temperature, since the refinement for our thermometer is only to the tenth of a degree. So what this is really saying is that that person's temperature is in between 98.6 degrees and 98.8 degrees, somewhere in there. And the reason is we don't know how the thermometer is rounding. So was it that the temperature actually was 98.6 degrees, in which case we would round up to 98.7 degrees, or was it that it was 98.74 degrees and we rounded down to 98.7 degrees? Since the refinement is on the tenth, anything happening in the hundredths or beyond we wouldn't be able to pick up, and so it's just an approximation. Okay, it's just things to keep in mind. It's not that these really play into how we conduct business and statistics. It's just good to keep that in mind, that even if you have two patients that have the exact same temperature, they really don't, or it's impossible to determine if they do, because we're really dealing with a range or this interval of values. Okay, when it comes to measuring variables, we have a few different scales of measurement that we can use, and so let's look at those. So measurement scales. Okay, so often, and maybe we can break these down for discrete versus continuous, but let's not do that entirely. But for example, in a discrete variable, it might be a person's gender, in which case then it's male or female, and then it's really just a name that we're applying to it. It's not, you can't measure I don't know, I'm not going to go there. I suppose you can't measure the maleness or the femaleness of something, but let's just gloss over that one. In terms of scales, though, we might have just a naming scale, and we'll call that a nominal scale. So again, just referencing the name, and this would be for categorical variables, so categories. So it might be gender, it might be occupation, it might be color of an item, it might be condition of an item. So if you're selling an item, you might say that your item is in mint condition, good condition, like new condition, poor condition, in which case you're just giving a name, and then everybody else interprets what that might mean. And there might be conditions that you put onto naming something, but as a whole it's more subjective, or these are categories that have just a name and there's no real numerical value that can be put to these. Okay. The other scale that's often used with discrete variables would be the ordinal scale. Ordinal scale. And so for this one, think ranking or ordering. So in other words, if you were going to classify something as the best, in terms of first place, second place, third place, so first versus second. So these are the ordinal numbers. It could also be something like GPA, in terms of just like an A corresponds to a value of 1, a B corresponds to a value of 2, and an A is better than a B. And so there's a distinct ordering to these. It's not that it's the best or the worst or something, it's just a definite ordering, 1, 2, 3. We could also apply it to Yeah, I guess like quantifying the scale, the size of something. How many times larger are you? Well, no, let's hold off on that one. We're going to put that one to the interval scale. So this is kind of transitioning into the continuous variables. So we have what's called the interval scale. Okay, and this one is, yeah, like I said, a comparison typically, but the real distinction here is that there's no absolute zero or no definite zero spot. So no, I'll write no absolute zero. Okay, or in other words, zero does not indicate a lack of something. It just means that in terms of size comparison, you're the exact same size as something else. And so an example, if we look at height, I might say that I am 10 inches taller than Jim, let's say. But that doesn't tell you how tall Jim is, and it doesn't even tell you how tall I am. It just tells you how many units, greater than Jim or less than Jim or something like that. So if I were to say I'm 0 inches taller than Jim, it doesn't equate to a lack of height. It just says that I'm not taller than Jim, and so we have the same height. So the key for this scale of measurement is that you have to have equal intervals, or I should say definite intervals. So in other words, you have to put a unit to it, inches or degrees or... Okay, so units would be important here. I can't say that, if I were to say that I'm, 2.5 times taller than Jim, yeah, I guess that works, but it's still implying that you have an original measurement and that you both were in that measurement. Okay, and really that's driving at what we call the ratio scale. Okay, and the ratio scale is an improvement over the interval scale in the sense that it actually has an absolute zero mark. So in other words, if I'm just giving my height, I could say that I am, if I was, let's say, 6 feet tall, then I am 72 inches tall. This is the exact height that I am. Notice the units here I'm putting in inches, and I'm giving a definite label, and that is different than being 50 inches tall. Okay, even though with the interval scale I might say that this person here is 22 inches taller than this person, this 22 inches doesn't actually correspond to the height. It's just a comparison. And so with the ratio scale, we actually give the exact height or exact temperature or exact weight or whatever the thing we're measuring, we give the exact value, and we can have something be 0 inches tall, and now this equates to no height. Right? If I had somebody else that was also 50 inches tall, this person is 0 inches taller, which is to say not that they don't have height, but that they are the same height. But on the ratio scale, we have the ability to say that something does not possess a measurable quantity of whatever it is that we're looking at. So height, if we say that somebody is 0 inches tall, the absolute zero value corresponds to no height. Or if we say that something has a 0 weight, that means 0 pounds, for example, that means it has no weight at all. Okay, no measurable weight. On the flip side, if we go back to this idea of the interval scale, I might define something to have a weight, a temperature of 0 degrees. I might say 0 degrees, but what does that mean? Okay, so if it's, let's say, Celsius, is that how you spell Celsius? Let's just put it in with a C. 0 degrees Celsius. This corresponds to freezing, but it doesn't mean that it has a lack of temperature. So this does not equate to lack of temperature. In other words, you could still measure that temperature. In fact, you can have something with a negative temperature, right? And it doesn't mean that it doesn't have temperature, it just means that it's less than freezing, and so it's not a absolute 0 point. Okay, it's just a relative 0 point in terms of comparison. So I'm 2 degrees Celsius less than freezing. Okay. So when you want to try to decide what scale to use, the way we would distinguish between, let's say, nominal scale versus ordinal scale, well, the key here is if you can order or rank. Okay, so rank is how we would distinguish these. So if you need to place something, this one first, then this one, then this one. So we have first, second, third. Even though these are names, we might say that this person is in first place. It's a definite ranking that is different than being in second place. But if you were to put a name to it like color blue, does blue go before red? Does it go before yellow? Does yellow go before red? There's no definite order to those. Okay, when you want to make the distinction between interval and ratio scales, we use, so both of these have to have units. Maybe I'll put that in another color. Both of these have to have units. Units. Okay, but the difference comes, this has an absolute 0 marker, whereas this one has an arbitrary 0. Arbitrary 0. Okay, and that's how we distinguish between interval and ratio scales. Alright, well, I think we should take a look at an example coming from the textbook. So this is an example coming from page 50, example 15, number 15, coming off of page 34. Okay, so I'm choosing this one to kind of also explore an experiment and the parts of an experiment. Okay, so in an experiment examining the effects of Tai Chi on arthritis pain, Callahan in 2009 selected a large sample of individuals with doctor-diagnosed arthritis. All right, so half of the participants immediately began this Tai Chi course, and the other half, the control group, waited 8 weeks. So the control group, the do-nothing group, the Tai Chi group, the experimental or the treatment group, and they waited 8 weeks before beginning the program. Okay, so that was how we were able to control this, and then the manipulation comes from, giving the class, the Tai Chi class, to half the group, and the other half got nothing. So that's how we manipulated this. At the end of the 8 weeks, the individuals who had experienced Tai Chi had less arthritis pain than those who had not participated in the course. Alright, so since this is an experiment, we have an independent variable and we have a dependent variable, also called the response variable. So with the independent variable, what are we manipulating? What's the thing that we are controlling in this experiment? Well, if you look at this, the people selected all had arthritis, a doctor diagnosed arthritis. It doesn't mean that they all had the same amount, but we're going to expose half of them to Tai Chi and the other half will wait. Okay, so the independent variable would be the presence of Tai Chi. So let me write Tai Chi, yes or no. Okay, so that would be the independent variable. And since this is yes or no, what would be the scale of measurement for the independent variable? Okay, does that, in other words, is yes are there infinitely many choices for yes? Well, no, that's a discrete variable. There's only 2 cases, yes or no. And since it's not an ordering, we would say that this is a nominal scale. Right? So it's just a name. Yes indicating that they were in the group, or no indicating that they were not in the Tai Chi course. Okay. Now, what was the response? So if I manipulate if the participants are in a Tai Chi course or not, what is the thing that I'm measuring after the fact? So when you look at this, it says at the end of the 8 weeks, those who had been in the Tai Chi had less arthritis pain. And so the thing that we are measuring is either the amount of arthritis pain or the level of arthritis pain. So I'll write amount or level of arthritis pain. Since we weren't given the kind of ranking of pain, or how they're going to measure, we don't have that operational definition. We don't know, how they, measure less. Did they measure it, as saying like the people in the group had less arthritis pain than the average of those who had not participated, or less than when they first gave their ranking, or are they using some other pain indicator like brain activity? I don't know how they're doing it. And so when it comes to the scale of measurement, it might be that the scale of measurement is the interval scale, or it might be the ratio scale. So depending on the condition, and if I wanted to look at the measurement of arthritis pain, if we were comparing, so in other words, if the treatment group, if we were comparing the average pain level ranking wise, if they ranked it on a scale of 1 to 5, we compare that with the average ranking for the control group, and we saw that it was less, then I would be using the interval scale. So this would be for a comparison of scores of pain levels. Okay, but if we were having them rank it on a scale of 0 to 5, let's say, where 0 corresponded to no pain, well, since that's an actual lack of pain or an absence of the thing we're measuring, then we might be talking about the ratio scale. So if we were just having them rank and giving them the possibility of a score of no pain, then we would be measuring using a ratio scale. Alright, so section 1.4, we're dealing with variables and how do we measure variables. We had some ideas like an intrinsic characteristic would be called a construct, which would make an operational definition important. We need to know how are we going to measure this and what would the measurement mean. And then if we were dealing with a variable of any kind, how would we measure it? What kind of scales will we use, and what kind of variable is it? Is it discrete or is it continuous? And if it is, let's say, discrete, is it coming, the scale of measurement, is it nominal or ordinal? If it's continuous, is it an interval scale or a ratio scale? And again, we told the difference between nominal and ordinal by ranking. Ordinal means ranking, and the interval versus ratio scale, we told the difference by looking at the presence of an absolute zero marker, so the lack of whatever value we're measuring. Okay.